Hello and welcome to 8.5 Partial Fractions. Probably one of my favorite sections in this book, if not this course. I mean, in this course, if not in this book, that's the right way I should say. Okay, partial fractions. Another technique to integrate a rational function is to decompose the rational function into smaller rational functions which are easier to integrate. So decomposition of nx divided by dx, and a numerator d for denominator, into partial fractions. Divide if improper. So if it's improper, higher power on top, you divide first. So if it's improper fraction, divide the denominator into the numerator to obtain nx over dx equals a polynomial plus n1x over dx, where the degree of n1x is less than or equal to that of dx. Then apply the following steps. I'm going to go over here and scroll this. So step 2 says factor the denominator. Completely factor the denominator into factors of the form px plus q to the m, and m could be 1, and ax squared plus bx plus c to the n, where ax squared plus bx plus c is irreducible. Linear factors. For each factor of the form px plus q to the m, the partial fraction decomposition must include the following sum of m fractions. Fractions. a1 over px plus q to the 1 power, a2 over px plus q to the 2 power, plus am over px plus q to the m power. So whatever the power is, you're going to continue to put these fractions there, and you'll have different powers on top. Now trust me, it's not going to be as complicated as this looks. This is a very general definition. Note though, you have a constant on top. It could be the same, it could be different. Over px plus q, this is linear, this is constant, 1 degree less on top. Down here for quadratic factors, for each factor of the form ax squared plus bx, not bs, plus n, the partial fraction decomposition must include the following sum of n fractions, b1x plus c1 over that quadratic, b2x plus c2 over the quadratic, all the way till you have n of them. Okay, so use partial fractions to find the integral. Now 1 over 4x squared minus 9, think of that as 1 over 2x squared minus 3 squared, or 1 over 2x minus 3 times 2x plus 3. Okay, and with that, we decompose it. There's only one 2x minus 3, there's only one 2x plus 3, so it's going to be a over 2x minus 3, and I'm going to say it plus b over 2x plus 3. The above coefficients, they give you a1, a2, a3. If we're dealing with a really big one, and maybe we're going to have 20 or more than 26 terms like this, yeah, you might need that. We're not going to be dealing with that. You can go a, b, c, d, e, f. So the way this works is we can find a value for a and b. Watch this. So 1 over 2x minus 3 times 2x plus 3 equals a over 2x minus 3 plus b over 2x plus 3, just as I've defined. But now I'm going to clear the fractions, clear them out. Multiply by 2x minus 3 times 2x plus 3. 2x minus 3 times 2x plus 3. 2x minus 3 times 2x plus 3. So on the left side, these just divide out. You're going to have 1 equals. On the right side, this divides out, and you'll have an a times 2x plus 3 plus b times 2x minus 3. Now you can distribute through a couple of approaches at this point. You could put in certain values to make this term 0 and so on. So for example, if we said, or we can distribute through and solve a system of equations. If we say x equals negative 3 halves, negative 3 halves, and for x, that gives us the result of saying 1 equals a times 2 times negative 3 halves plus 3 plus b times 2 times negative 3 halves minus 3. Well, this part's just 0. So we have 1 equals b times negative 6. So b must be negative 1/6. Divide both sides by negative 6. In the second case, if we said x equals positive 3 halves, we would have 1 equals a times 2 times 3 halves plus 3 plus b times 2 minus 2 times 3 halves minus 3. So that's 1 equals 2 divided by 2 is gone. A times 6 plus b times 3 minus 3, that's 0. So it's gone. So divide both sides by 6, a is 1/6. Okay. I want to show you how we got the negative 3 halves and the positive 3 halves. 2x plus 3 equals 0. Two x equals negative 3, x equals negative 3 halves. So that's where this one would be 0. I chose it on purpose. Positive 3 halves makes this one 0. So you can set the factors equal to 0 to determine what you can substitute into them. And this works most of the time. Some cases it doesn't work. So we're not finished though yet, because what we have then is the integral of 1 over 6 1/6 times 1 over 2x minus 3 minus 1/6. Why minus 1/6? Because b is negative 1/6. 1 over 2x plus 3 dx. Okay. So I hope you have this, because I need to erase this. So if you don't have it, pause right now. Okay. I'm going to go ahead and erase this. This becomes 1/6 of the natural log of the absolute value of 2x minus 3 over 2, because the 2 right there, minus 1/6 natural log of the absolute value of 2x plus 3 over 2 plus c. So our final answer will be, well, I won't go to the final yet, 1/12 natural log of the absolute value of 2x minus 3 minus 1/12 natural log of the absolute value of 2x plus 3 plus c. So these can be combined because of the subtraction. So it's 1/12 natural log of the absolute value of 2x minus 3 over 2x plus 3 plus c. And that's the end of that problem. Okay. What I think is really cool about this is the way we can take something like this that's factored and break it down. We've got a little more complicated fraction, break it down to less complicated fractions. That's what I think is a really cool thing about partial fractions. Okay. Let's go on to the next one. Next page. Use partial fractions to find the integral. And notice how we have a lot of space here. We are definitely going to use this space. Okay. We could factor this down, and we have a 4x squared plus 2x minus 1 over, you can pull out the x squared times x plus 1. This means, because the x squared, we're going to have a over x plus b over x squared plus c over x plus 1. So the reason it's b over x squared is because this is a repeated factor. It has multiplicity 2. So we have the first time, then the repeated time, but it's still linear. Okay, so we're going to have that 4x squared plus 2x minus 1 over x times x plus 1, x squared times x plus 1 equals x squared times x plus 1 times a over x plus x squared times x plus 1 times b over x squared plus x squared times x plus 1 times c over x plus 1. So this divides out, that divides out. The x squared and the x divide leaves an x here. X squareds divide out, and the x plus 1's divide out. We have a 4x squared plus 2x minus 1 equals a times, we have x times x plus 1 plus b times x plus 1 plus cx squared. Okay. Now, what would make x 0? Well, if I say x equals 0. So I'd have, plug in 0 in for x on both sides. 4 times 0 squared plus 2 times 0 minus 1 equals a times 0 plus 1 plus b times 0 plus 1 plus c times 0 squared. So on the left side I'll have a negative 1. On the right side I will have that 0. This is 1. 1 times b is 1. Well, as b, that's 0. So is b. Hey, b is negative 1. We found one of them. How about if I said x equals negative 1? What? Why negative 1? Because it makes the x plus 1's 0. So it'll be 4 times negative 1 squared plus 2 times negative 1 minus 1 equals a times negative 1 times negative 1 plus 1 plus b times negative 1 plus 1 plus c times negative 1 squared. So that's 4 minus 2 minus 1, that's 4 minus 3 is 1 equals c. So c is 1 and b is negative 1. So how about a? This is another way to do this problem. I'm not going to restart it. But for finding a, now notice that you have ax times x plus 1. You have 4x squared plus 2x minus 1 equals ax squared minus, or plus ax plus bx plus b plus cx squared. We can collect the coefficients now. So coefficients of x squared. On the left you have a 4, on the right you have an a plus c. They are both coefficients for x squared. We know that c equals 1, so it's 4 equals a plus 1, so a must be 3. So all that work, now that's a lot of work. Now here's the cool thing. Transforms this into the integral of a, which was 3 over x plus b, or I should say minus, plus b is negative 1, over x squared, plus c is 1 over x plus 1. This really complicated looking integral reduces down to this. That's really cool. That's really nice. Okay, so we have 3 times the natural log of the absolute value of x minus, now this is just x to the negative 2, so it becomes x to the negative 1 over negative 1, so that's going to change there, plus the natural log of the absolute value of x plus 1 plus c. So you have 3 natural log of the absolute value of x plus 1 over x plus natural log of the absolute value of x plus 1 plus c. Now you could be creative and bring this 3 as a power for the x and then combine the natural logs, but I'm going to leave it like this. Okay, I think that's pretty fun. Now I'm going to go ahead and move this up so we can do example 3. Okay, use partial fractions to find the integral. So it's x squared plus 5 over x cubed minus x squared plus x plus 3. So we see it is a proper fraction, smaller degree on top than bottom. When we look at x cubed minus x squared plus x plus 3, this does factor, I may have used a calculator for this, into x plus 1 times x squared minus 2x plus 3. So that when we have x squared plus 5 over x cubed minus x squared plus x plus 3, that's going to be equal to a over x plus 1. Now we haven't seen one like this yet. We have this x squared minus 2x plus 3 down below. So that's a second degree, 1 degree less is a first degree bx plus c. So if we clear the fractions out by multiplying by, and I should write this as x plus 1 times x squared minus 2x plus 3. So if we clear out the fractions, we will have x squared plus 5 equals a times x squared minus 2x plus 3 plus bx plus c times x plus 1. So we'll have x squared plus 5 equals ax squared minus 2ax plus 3a plus bx squared plus bx plus cx plus c. So this one, unfortunately, we can't do what we did in the previous where we were able to just eliminate stuff because this is prime. We can't just substitute something in and make it 0. So I'm going to change pens because this one's getting kind of dry. Hopefully this one's better. So at this point we'll look at coefficients. For x squared, on the left we have a 1, on the right we have a as a coefficient plus b. For x, on the left we have a 0, on the right we have negative 2a plus b plus c. And for the constants, on the left we have 5, on the right we have 3a plus c. Now we need to come up with, here's a relationship between a and b. So we could say that we have negative 1 equals negative a minus b if I multiply this by negative 1. In the next row we have 0. Multiply this, well, just bring this over. 0 equals negative 2a plus b plus c. And then bring in this last row, 5 equals 3a plus c. What happens if I add all these together? Negative 1 plus 0 plus 5 is 4. Negative a plus negative 2a plus positive 3a is nothing. Negative b plus b is nothing. C plus c is 2c. So c must be 2. Bring it in here. 5 equals 3a plus 2. 3 equals 3a. So a equals 1. Put it up here. 1 equals a plus b. So 1 equals 1 plus b. So b must be 0. So how does this transform? We end up with the integral of 1 over x plus 1 plus 2 over x squared minus 2x plus 3 dx. So it doesn't look as pleasant as the other ones we've done, but it's still very much doable. Integral of 1 over x plus 1 plus 2 over, now I want to make this a perfect square. That'd be x squared minus 2x plus 1 plus 2. So we have the integral of 1 over x plus 1 plus 2 over x minus 1 squared plus 2. It's starting to look like an arctangent to me. And then this will become natural log of the absolute value of x plus 1. I think we all see that one. I hope we do. Plus 2 times, this is an arctan, where our a is the square root of 2. So 1 over the square root of 2, arctangent of x minus 1 over the square root of 2 plus c. So 2 divided by the square root of 2, that's going to be natural log, the absolute value of x plus 1, plus square root of 2, that's how that reduces down, arctangent of x minus 1 over the square root of 2 plus c. And that's it. Let's go on to the next page. 2 more examples from this section, which is kind of sad because it's such a fun section. Okay, so 4 is no fun because it says use a computer algebra system to do it, so our calculators are going to do this for us. This says use a computer algebra system to determine the antiderivative that passes through the given point. Use the system to graph the resulting antiderivative. So I'm going to just show you, give you an idea what the graph looks like. Okay, so our integral of x squared plus x plus 2 over x squared plus 2 squared dx is the square root of 2 arctangent of square root of 2x over 2 all over 2 here minus 1 over 2 times x squared plus 2 plus c. And hopefully at this point you can put this in the calculator. If you have a question, please let me know. And I did this in TA89. So the graph of that looks like this. Okay. Now that gives us a particular point. We know it goes from 0, 1. So if we plug in 0, 1, we have here square root of 2 arctangent of the square root of 2 times 0 over 2, all that over 2, minus 1 over 2 times 0 squared plus 2 plus c. That's going to be the square root of 2. Arctangent of 0 is 0. Minus 1 over 2 times 2. Oh, I don't do plus c anymore. It's a particular solution. And, or actually, not even that. We're just plugging stuff in. We get negative 1/4. I should have kept that. Plus c equals 1. Yeah, I'm plugging it in. We're going to find our c. Plus c equals 1. So negative 1/4 plus c is 1. So c equals 5/4. So our solution is going to be y equals the square root of 2 arctangent of the square root of 2x over 2 all over 2. Excuse me. Minus 1 over 2 times x squared plus 2 plus 5/4. That's what I was after. Okay. Let's go on to example 5 here. It says use substitution to find the integral. Okay, we have the integral of sine x over cosine x plus cosine squared x dx. If I say u equals cosine x, my du is going to be negative sine x dx, and so of course negative du is sine x dx. So we'd have the integral of, put the negative out front, 1 over u plus u squared dx. That's going to be negative integral of 1 over u times 1 plus, I'll say u plus 1. I like to do it in descending orders. So when we look at 1 over u times u plus 1, we'll say a over u is equal to a over u plus b over u plus 1. So if you multiply through, 1 equals a times u plus 1 plus b times u. This one's an easier one. We can put in the zeros, put in numbers to make the factor 0. If I say u equals 0, I have 1 equals a times 0 plus 1, a equals 1. If I say u equals negative 1, we have 1 equals a times negative 1 plus 1 plus b times negative 1. So 1 equals negative b, so b equals negative 1. We have the integral, negative integral, of 1 over u minus 1 over u plus 1 du. Again, the minus came from b. b is negative 1. So that's going to be, and I guess if you want to bring this negative in, you have the integral of 1 over u plus 1 minus 1 over u. So natural log of the absolute value of u plus 1 minus natural log of the absolute value of u plus c. So it's natural log of the absolute value of cosine x plus 1 minus natural log of the absolute value of cosine x plus c. And we can combine these into natural log of cosine x plus 1 over cosine x plus c. You can play with this a little bit. This is a fine answer. This would be natural log, though, if you want to go further, of cosine x over cosine x plus 1 over cosine x plus c. Natural log of 1 plus secant x plus c. Whew, that was a fun one. And sadly, that concludes this section. Like I said, one of my favorite sections, probably my favorite section in all of calculus. So, thank you, and have a good day. I'll see you guys later, and send me your questions.